Hey everybody, in this video I'm going to be showing you how to do a one sample t-test, and we do that when we want to compare the means of some continuous variable to a known population mean. So I'm going to show you how to do this. This comes from chapter 6 of our textbook, Basic Statistics for the Behavioral and Social Sciences, and this is talked about in more detail in chapter 6 titled Comparing Samples. So I have the hospital data set loaded into my environment, and that's the data set that we talk about in this chapter, we refer to. And I'm going to view the variables in this data set simply by clicking that spreadsheet icon. And the question that we have, or the hypothesis that we want to test, is are the age of our hospital patients significantly different than the known population age of hospital patients of 61 years. So first we have our variables shown, so we can actually explore this variable a little bit more. We could require the psych package, which I've had already installed, and describe hospital and age. And we see that the mean age of our patients is 58.58. So they seem a little bit younger on average than the known population parameter of 61 years. And the standard deviation is 16.43. And our median and trim mean are similar to our mean. So to conduct this one sample t-test, we simply type into our console t.test, and the name of our variable is age. It came from the hospital data set, so we're going to use that convention of putting the data set followed by the $sign. And our population parameter, or our population sample, a population mean is 61. And if I hit enter, I can see what our one sample t-test results are. So first of all, our alternate hypothesis stated here is that the true mean is not equal to 61. Our null hypothesis is implied that the true mean is 61. And the results of our t-tests are above here. So we have our calculated t-value, we have 49 degrees of freedom, and our p-value. And notice that our p-value is greater than 0.05, so we are unable to reject the null hypothesis that the true mean is equal to 61. So statistically, that it implies that the age of the patients in our sample is very similar or the same as those in the rest of the population. The remainder of the output is the 95% confidence interval and the mean of our variable, which we had seen in the describe. And I hope you found this video helpful.